Hello, good morning, good evening, good afternoon. I'm Dr. Dave Albin, Vice President, Nutrition and Extrusion Technologies with Instapro International. And I'm going to briefly go through a PowerPoint on Express Meal and its use in dairy production. Um, Others can be found at our customer portal, and you can always reach out to us for more information if that is so needed. So I'm going to talk about some of the benefits of the Express process and what it is and why this meal can be used so effectively within dairy production, within a formulation. This is the express process, sort of anchored by our high shear dry extrusion process, which is right here on the left. That's the extruder. The dry high shear version that we developed and patented in the 1960s, and that when it's used, it imparts various characteristics to the soy meal that is useful for dairy producers. But this is where we have a short time, high temperature, pressure cooking process, um, which is then followed by the full fat soy traveling through the mechanical oil press. And this is very important from a dairy point of view because you're left with about 6 to 8% residual oil in the meal, which works far, far better within formulations compared to, say, full fat soy that's got 18% oil. That's far too much for the rumen, unless it's fed at very, very low levels. And it also imparts various characteristics in other animals as well, like broilers and layers and swine. So better ME, better metabolizable energy, which is useful for productive purposes. The amino acids are more digestible and there's less moisture, which means we have more concentrated nutrients. Particular to the dairy cow, though, is that the high shear dry extruder creates what's called rumen bypass protein. That means it's protected, it's much more protected from being altered by the rumen microbes, which are things like bacteria and viruses and protozoa. And those alter proteins that we're trying to give to the cow so that she'll milk more and produce more milk fat and milk protein. So by protecting that, by making rumen bypass protein through our extrusion process, we're making it a much more higher value meal. We also have some data that seems to point to better rumen function, better fiber degradation, higher rumen pH, so a better functioning rumen. And then combining that with the oil press, which, as I said, lowers the residual oil levels, this also seems to be creating some rumen bypass fat. So just like we have rumen bypass protein, we also want the fat to not be altered by the microbes and to be used to support milk production. And we seem to be doing that as well. So this is the rumen. Everything that the cow eats goes in there. That's where all the microbes are. That's where all the bacteria are. Then they alter everything that the cow eats. If we're trying to feed the cow, though, to have more milk and more components, we want most of the protein and oil or fat to bypass this rumen and then go on into the intestine and feed the cow. And so that's what we're doing. And that's shown here quite well. You can see that as we run at our optimal processing temperature of 160 C, we take raw soybeans, which have a very low bypass value, and create a very high bypass value, typically 65 to 70% in the field. And the other thing that we're doing is with our process, we're not damaging any of these proteins. So you can see digestibility in the small intestine is still very high. So most of the bypassed past protein is being used by the cow for productive purposes. And once again, this all comes back to our process. It's a high temperature, short time cook process that is adequate at performing cooking and deactivating anti-nutrients and rupturing plant cell walls, but it does not overcook, right? It does not damage proteins or fats. We do a lot of what we do because of university research. These are particular to dairy, some of the key papers, some of the key findings. You can see we've compared Express to other soy products in the marketplace. We've even done some work on full fat, which is fine to use, but only at very very low levels. So this is what drives us our animal feeding trials for all species, not just for dairy. And this is how we develop and revise our process. So we're going to talk kind of briefly here about a trial that we did back in 2021 at Penn State University. We were looking at both extruded corn, which we call high gel corn from our extruder, and express meal, feeding that to dairy cows, seeing what happens in terms of performance, production over 21 days. And that's shown right here. This is milk production. You can see with that dark green line at the top, that's the treatment where they were fed dry extruded corn, high gel corn, and express meal. And you can see that we got about 4.5% more milk production compared to cows that were fed steam flaked corn. So in this case, it seems to be important to have both express meal and extruded corn, high gel corn. That's where we had milk production maximized. But talking about express meal only, you can see that that by itself in this orange bar also generated a higher milk production compared to, say, canola meal. Sometimes you'll see dairy nutritionists will say, "Oh, I can get some cheap canola meal, or I can get some other oilseed meal," and those will always be inferior. We also looked at milk revenue divided by non-forage feed costs. So this is the more milk production and that value divided by the higher costs of some of these ingredients that go through our dry extrusion process. And to make a long story short, if you look at the orange bar, even though it was the most expensive diet, the cows that were fed high gel corn and express meal, skip all these. So we can sort of quickly note here that we've got, as I said, 50 years of feeding trials to back up what we're doing. This was mainly about dairy, but as you'll see on this portal, we have data for all species. And you can oftentimes you can use express meal to reduce diet costs by taking